Hello class, it's Miss Rania. Today, inshallah, throughout this week, we are going to be continuing Chapter 4, Atomic Structure, Lesson 4.3, Distinguishing Among Atoms. We are going to find it in our textbook, pages 112 to 115. When it comes to the objectives we're going to fulfill today, we're going to identify the atomic and mass number, we're going to calculate the number of neutrons in an element, and we're going to investigate how isotopes of an element differ. When it comes to our keywords, we have atomic number, atomic mass, isotope, and mass number. Let's first recall an atom, then talk about its components. Last week in section 4.2, we agreed that an atom is the smallest particle of an element that retains its identity in a chemical reaction. There are some parts of an atom. Can you recall them? Okay, let's see. The three parts of an atom are protons, neutrons, and electrons. Of course, protons are positively charged and are located inside the nucleus. Neutrons are neutral. They have no charge and they're also located inside the nucleus. Whereas electrons are negatively charged and are in the electron cloud. So they are around the nucleus, not inside the nucleus. So we agreed that atoms have different parts, but how are atoms different? Let's take a look at a hydrogen atom and an oxygen atom. This is the element key for an oxygen atom. We'll find it in the periodic table. And this is an element key for a hydrogen atom, which we also find in the periodic table. First of all, let's look at the atomic number. So what is an atomic number? Simply, an atomic number is the number of protons. So, an atomic number is the number of protons in the nucleus of an atom. So, when we look at the element key in the periodic table, first of all, this 1 and this 8 at the top are our atomic number. We can find it simply and clearly in the element key in the periodic table. The numbers at the bottom are the mass number, which we're going to talk about in a while. So keep in mind, the atomic number is number of protons and number of electrons. They're equal, okay? So we can tell the first difference between a hydrogen and an oxygen atom is the atomic number. As for hydrogen, the atomic number is 1, whereas for oxygen, the atomic number is 8. Keep in mind this, that atoms are electrically neutral. So the number of electrons must equal the number of protons. Let's take a question. How many protons and electrons are present in this atom? Which atom? Let's see. Let's take fluorine. If you go to the element key in fluorine, you're going to find at the bottom, which we agreed is the mass number, 18.99. Whereas at the top, we're going to have 9, which is the atomic number. We discussed that the atomic number equals number of proton equals number of electrons. So what is the atomic number in this case? Our atomic number is 9 because we already agreed at the top atomic number, at the bottom atomic mass. So atomic number is 9. And since the atomic number is the number of protons and electrons, so I have 9 protons and 9 electrons. So far, we discussed the atomic number and we found the number of protons and number of electrons. Let's move on to the mass number. What is the mass number? Think about it for a second. It's what part of an atom is the heaviest or with the highest mass? Well, most of the mass is concentrated in the nucleus of an atom, as it holds both protons and neutrons are in the nucleus of an atom. So it is technically the heaviest part of an atom. So by this we can conclude that the mass number is number of protons plus number of neutrons, because we're talking about the heaviest part of an atom, and the heaviest part in the nucleus, and the nucleus contains protons and neutrons. So this way we can simply find the mass number. Let's take a look. To sum up the formulas we took so far, the atomic mass is the number of protons and is the number of electrons. So atomic mass equals protons equals electrons. Whereas the mass number is the protons plus neutrons. And the number of neutrons, we are going to get to it. So let's take a look at fluorine. 9 atomic number, 18.99 atomic mass. Or we can say mass number. So here, atomic number, and here we have the mass number. So far, we found the atomic number, which is the protons and the electrons equally. So 9 equals atomic number equals protons equals neutrons. And the mass number is protons plus neutrons. So we have as well 18.99, and here we have 9. But we missed one thing. What about the number of neutrons? Okay, let's talk about the number of neutrons, and this way we discussed the parts and the roles and how they're related to all the subatomic particles. Protons, neutrons, electrons. Now let's talk about the number of neutrons. Number of neutrons is also found using the element key in the periodic table, because the number of neutrons is the mass number minus atomic number. So in the case of fluorine, mass number is the one at the bottom, so it's 18.99 minus the atomic number, which is at the top, 9. So 18.99 minus 9, we get 9.99. Let's take another example. How about the number of neutrons in lithium? Also, immediately go back to the periodic table, look at the element key, 3 and 6.99. So when we want to find the number of neutrons, it's the it's the mass number minus atomic number. So we have 6.99 minus 3. So 3.99 as the number of neutrons in a lithium atom. I hope everything was clear so far. In the next video, inshallah, we're gonna discuss isotopes. Hello class, it's Ms. Rania. We're continuing the last part, or actually the second part of lesson 4.3, distinguishing among atoms, pages 112 to 114 of chapter 4. The objective we're fulfilling in this part of the video is investigating how isotopes of an element differ. Our keywords are atomic mass, atomic number, isotope, and mass number. All atoms of specific element have the same atomic number. And so this means that the number of protons is the same too. But sometimes we have heavier atoms of a particular element. Those atoms have higher mass. Keep in mind, mass number is the number of protons plus the number of neutrons. And we agreed that the number of protons is always the same. It never changes because it's technically what gives the chemical properties to each atom. And electrons are so tiny, so we can simply ignore their tiny mass. So we're left with the number of neutrons. So atoms, isotopes, are atoms that have the same number of protons but different number of neutrons. And in calculating the mass number, we already know that mass number equals number of proton plus number of neutrons. And since the number of neutrons is different, then the mass number will be different. Let's take a look at a carbon and a nitrogen atom as the element key from the periodic table. Both have different atomic mass, 7 and 6. When it comes to the atomic number, the mass number, it is also different. This tells me they're not isotopes. They're completely different atoms. Let's take a look at another example. For example, we have these carbon atoms with the same atomic number, 6, which is perfect, and different mass number. This can tell me they're simply isotopes. Why? Because atomic number is number of protons, that never changes. Mass number is the number of protons plus neutrons, which means that if we rearrange the formula, we can simply find the number of neutrons. So the number of neutrons is mass number الحمد لله. انا حاساها بتطلع وبخلص الفيديو قاعده
ملاحظه اصلا حاجه جنبين المكالمات